The effects of a drug depend on its site of action and dose. Psychoactive drugs affect conscious experience by altering the function of the brain. Drugs can be developed to interact with one or more receptor subtypes, even when neurotransmitters can interact with various subtypes, whether they selectively activate or block that subtype. Drug molecules spread out throughout the brain and bind with the receptor molecule that they seek. The lock and key analogy says that each drug molecule, or the key, temporarily binds or fits to the receptor or lock. The right match activates or blocks the receptor. Drugs typically bind strongly to one receptor, weakly to some, and not at all to many others. The degree of chemical attraction between a ligand and a receptor is called binding affinity or just affinity. The drug will bind to the receptor even at low doses when affinity is high. When affinity is low, the drug will still bind, but it will just need to be a higher dose in order for the effects to be seen. Weak binding leads to rapid dissociation from the receptor. The likelihood that the ligand will activate the receptor is called efficacy. Agonists have high efficacy and antagonists have low efficacy. Partial agonists produce a moderate response. Affinity and efficacy means where it binds and what it does, and these put together determine the overall action of the drug. The greater the dose, the greater the effects that are produced. This relationship is plotted on a dose-response curve, or DRC, and this is a main tool for understanding pharmacodynamics. Our body systems adapt to environmental challenges, and drug treatments are considered one of such challenges. This adaptability is called tolerance, leading diminishing effectiveness of the drug over time. Metabolic tolerance is when the body's metabolic systems and organs eliminate more of the drug from the bloodstream before it has a chance of affecting the target. Functional tolerance is when the number of receptors present on the cell membrane changes. Repeated exposure to an agonist causes downregulation, which decreases the number of receptors on the membrane, and repeated exposures to antagonists cause upregulation, which increases the number of receptors. Cross-tolerance is when the body develops a tolerance to all drugs belonging to the same chemical class as the one it has already become tolerant to. Drug tolerance is believed to be involved in withdrawal symptoms, and some drug responses become stronger at treatment as treatment continues, and this is called sensitization, which may contribute to drug cravings. The drug's route of administration determines the amount of drug that reaches the brain and the speed at which it starts to act. The biotransformation of drugs is what makes the metabolites of the drugs active. Pharmacokinetics include the factors that affect the movement of drugs, like into, through, and out of the body. The blood-brain barrier is a major obstacle for drugs, since it makes it more difficult for large molecules and foreign substances to enter the brain. Drugs affect each stage of neural conduction and synaptic transmission. Local anesthetics block sodium channels to stop neural transmission in pain fibers. Drugs that change behavior do so by changing the choreography of synaptic transmission. Some drugs alter presynaptic events. A drug may alter the process of transmitter production. Axon terminals must receive raw materials and enzymes in order to synthesize structures involved in synaptic transmission. Some drugs inhibit enzymes, prevent essential materials from reaching the axon terminals, or interfere with the neuron's ability to store catecholamine transmitters in synaptic vesicles. A drug may prevent the release of a transmitter by blocking sodium channels, which prevents action potentials from firing, block calcium channels, which would prevent the release of transmitter into the synapse. Neurons use autoreceptors to keep track of how many transmitters they release. Transmitters are immediately removed from the synapse through reuptake and degradation, Reuptake involves transporters which remove them from the synaptic cleft for reuse. And degradation is the process of breaking down a neurotransmitter.